Okay, section 9.6. Translate and classify conic sections. No longer can we assume that the center is 0, 0 or the vertex is 0, 0. So we have to know some formulas. Let's do a circle first. So, circle, you know, is x squared plus y squared equals r squared. All of our formulas are going to change. But the easy thing about this is, instead of x, you're always going to have x minus h. Okay? In this case, squared. Plus, instead of y, you're always going to have y minus k squared equals r squared. So any formula you know already, instead of x, you're going to put x minus h. Instead of y, you're going to put y minus k. And what that does is, it comes up with hk is going to be our center, or in the parabola case, it'll be our vertex. Okay, but in this case, it's a circle, so our center is h comma k. So if you look at this over here, x minus h. H is equal to not negative 2, but 2. Remember, x minus h. So x minus 2 is h, and k is equal to y plus 3. It has to be y minus k. So it has to be y minus negative 3. That's why k is negative 3. So if this is h and k, we know our center now. Our center is h comma k, so 2 comma negative 3. We can graph that. 1, 2, comma, negative 1, 2, 3. There's our center of our circle now. We're going to have a circle down here. So, what else do we need to know to make this circle? Well, this is r squared, right? So if r squared is 9, that means r equals 3. So therefore, we have a radius of 3. So all you have to do is go up 3, 1, 2, 3, down 3, 1, 2, 3, 1, 2, 3, left 3, and right 3, 1, 2, 3. There we go. We got 4 points. Draw your best circle. Not too bad. There you go. You just graphed the equation of a translated circle. So the radius idea doesn't change. This side is still r squared. So if I said, hey, if I give you this equation, I say, hey, what's the radius? And it's square root of 9. 3. But if I say graph this, you have to know your center, which was here. H comma k. Circle is pretty easy. So let's go to our next one. Example number 5. What we're going to do is identify the lines of symmetry. Kind of like what cuts it in half. What maps it onto itself for each conic section. So for a circle here, if you have a circle with any center, where's the line of symmetry? Well, here, here, here. I could draw another one here, right? That would cut it in half and it would map it onto each other, right? If I folded it on that line. Really, so there would be any line that goes through the center is a line of symmetry, only for a circle, right? So I could just keep drawing lines, right? That line, any line. There's an infinite number of lines that I could draw. So what you would say is, if it said identify the lines of symmetry, you would say any line that goes through the center of the circle. So you would say this, any line through the center, which then they say the center is 2, negative 3, okay, is a line of symmetry. That's what you would say if I asked you on a quiz and test, which I probably will. So for a circle, that always happens. Lots of lines of symmetry. What about this one right here? This is a, what is that? Hyperbola, right? It's with a different center though. This center, that's what we're doing today, is different centers. This center is negative 1, 3. Now, what do you know about line of symmetry? Where does it cut it in half? Where would it map it onto itself? Well, if I drew a line here, which the red line right here if I folded that, if I had a piece of paper and I drew that red line on it and I folded it, wouldn't it map right onto itself? It would fold right onto itself, right? So there's a line of symmetry here. And then even if I drew one here and I folded it on that line, if it was a piece of paper, it would map onto itself. So for a hyperbola, there are two lines of symmetry. Where at? They both go through the center. So that's the key. Look for the center. So in this case, this is y equals 3 because y is 3. And in this case, x equals -1 because of this. So pay attention to where the center is in actually for all these things. So if I ask you this question, you would say x equals -1, y equals 3 are lines of symmetry in this case. Alright? Next one, this is just a parabola, right? As you can see, there's only one red line. If you drew this line, it cuts it right in half, and that point is 2, 3, which means y equals 3 is the line that cuts it in half. Notice there's not one going vertically, right? That's because no vertical line I draw will cut this thing in half. So, therefore, there's only one line of symmetry through the, not center, but vertex. So pay attention to the vertex. So you would say, hey, y equals 3 is a line of symmetry. Last one, you have your ellipse here. There's two lines of symmetry. One cuts it in half this way, which is wherever the center is, 4, 2. Okay, so this is y equals 2. And then one cuts it in half this way, x equals, in this case, 4. Alright, just pay attention to the center. That's the key of all these problems, the center or vertex. Okay, so you would say those two, x equals 4, y equals 2 are your lines of symmetry. Pretty easy, right? I mean, that's some easy points on your quiz or test. So, there we go.